Hello, viewers. This video series, we'll be looking at determinant, which is 11.4. So we'll start with the determinant of matrices, 2 by 2, 1 by 1, and for any n by n. So firstly, determinant is only associated with a square matrix. It means the matrix has to have the same number of rows and the same number of columns. So if you have a 1 by 1 matrix, the determinant is just that element. So if you have A, the matrix A equals to, for example, 2, its determinant is just that element 2, right? Then for 2 by 2 matrix, the determinant is nothing but what? Just the product of the diagonal, the main diagonal, minus the product of what? The minor diagonal. So determinant can be represented by like an absolute value. So that is why we see either you use this word, the depth of A, or you use the absolute value of A, which also means determinant. So for example 1, to find this determinant, it's simply 6 times 3 minus 2 times minus 3. And this will give us 18 plus 6, which is 24. Okay, so the minus here comes from the formula, but we also have another minus here, which is from the element B. Right. So for number 2, it says that we should find the solution sets. This is telling us that the determinant is 1 over 2. So it means we have to find what is alpha. So just apply the definition. It will be sine alpha cosine 2 alpha, then minus, this times this will cancel, so we have minus sine 2 alpha multiplied by minus cosine alpha, and this is equals to half. All right, so this will be sine alpha cosine alpha. Reduce the thickness. Okay, then this will be plus, this will be sine 2 alpha, this is cosine 2 alpha, and this is, we can see this as cosine alpha sine 2 alpha, and this is equals to 1 over 2. And carefully, this is nothing but sine so this is sine alpha minus 2 alpha, it's equals to half, and this is nothing but sine minus alpha, that's equals to half. And now since sine is odd, the minus can come out, so we have minus sine alpha is equals to 1 over 2, which means that sine alpha Now we want to solve this equation. You know what that means. This sign is negative in either the third or in the first quadrant. So we'll get our reference, which is going to be 30 degree. We can use degree, or we use it in radian. So if we're in the third quadrant, what will be this? So in the third quadrant is going to be just 180 plus what? So it means here alpha is just going to be 180, which is what, 210. And then you can add 360n. Then if you're in the fourth quadrant, alpha will be what? 360 minus, which is going to be 330 degree, and we can add 360n. So here n is what's an integer. So this is the general solution. Now for 3 by 3, how do you find the determinant of 3 by 3? We use this method. So this is what we call Saros method. We call it Saros method. I think Saros method. Now, how does this work? This method only applies to 3 by 3 matrix. So if you want to find the determinant, just repeat the second column, the first two column. Repeat the first two column. As you can see, this is A11, A21, A31. Then you draw lines to connect the main diagonals and also the minor diagonals. So the main diagonals are the ones in blue. So this one. Then the minor diagonals will be the ones in red. So you subtract the minor diagonal from the main diagonal. The sum of the minor diagonal, you subtract it from the sum of the main diagonal. And that will give us the determinant. So let's apply that to example number 3. So all we need to do is we have it to be minus 2, 3, 3, 5, 1, 0, 4, 2, 1. Then we augment this with minus 2, 3, 3, then 5, 1, 0. So once we have this, then we just need to draw lines. So we can see that this and then we can okay, I think this is 3. All right, now it means that the determinant of A simply the product of what's the main diagonals here. When I say the main diagonal, it will be the one in blue. So this will be 4 times what? You just see the product here. So this is 4 times 3 times 0. So this will be 0. And here will be plus. This is 5 times. Okay. So we have, should be 0. And this will be 5 times 2, which is 10 times 3. So this will be plus 30. And then you have minus 2 times 1. So this will be minus 2. Then we're done. Then now you subtract from the green ones. The green one, you can go 3 times 1 times 4. This is going to be 12 plus 0. I think plus what's plus 15. Okay. So this will be 28 minus 27. And the determinant is just equals to 1. Now, one thing here is that if everything is done correctly, if you draw your diagonal lines correctly, these two elements are supposed to be free, always free. All right. So this is how to use the Cyrus method. Now, let's see another example. For this one, we're told that what? The determinant is equals to 0, so you want to find x. So what we do is just you write your x to minus 1, then x again, 1 plus x, 0, 0 to then now we have to repeat this one. So this will be x to minus 1, x to minus 1, then x, 1 plus x, 0, right? Now, what do we do? What we're going to do is just same. We draw the diagonal lines. We connect the main diagonal. So let's start with the minor diagonals. So the minor diagonal will go something like this. So the main diagonal will connect this, and this one, right? So just like I said before, you see that these two, they are free. All right, so here already we are told that the determinant is 0. So the determinant is 0. It simply means that what? It simply means that if the determinant, so the main diagonal is the blue one, so this will be what? It's just going to be 0. And So this will be what? Minus 2x, right? Then plus, this is going to be x squared, 1 plus x. Now we subtract from the minor diagonal. And which one is the minor diagonal? This will just be 2x in a way. You can start in anyone. This is 2x squared thing. Then plus what's 0 and also 0. So this is what we have. And this should be equals to a 0, which is the, if you subtract this, you should get 0, because that is the determinant. And now this will just be minus 2x plus x squared plus what? Think x cubed minus 2x squared. This should be 0. And what do we have here? So let's rearrange. So this is x cubed. X squared minus 2x squared is what? Is minus x squared. Then we have minus 2x equals to 0. We can factorize by taking out x. So you have x squared minus, yeah, so this would be x squared minus x, then minus 2 equals to 0. So this is x. And this will be what? This is minus 2 plus what? Plus 1 equals to 0. So we have x is equals to 0, x is equals to 2, or x is equals to minus 1. So that is the solution set. So solution set is simply 0, 2, and minus 1. Okay, so now let's move to the determinant of n by n matrix. So for n by n matrix, and how do we find the determinant for n by n matrix? All right. So for this one, we need to look at what we call the minor and the cofactors, the minor and cofactor.